Okay, recording has begun. I'm Jamie Cuddy. I'm the Public Information Officer for the Portland Water Bureau, and I will turn this press conference over to Tim Collins.
Hello, good morning. My name is Tim Collins. I am the project manager for the Willamette River Crossing project. I've been working for the Bureau for actually just over 22 years. My anniversary was on the 13th of July. I'm a civil engineer, geotechnical engineer by training, and I've been working on this project for almost going on 5 years now. So to give a description of what we're doing, as you may be aware, the Portland metro region has some seismic hazards that are inherent to where we live. And so we currently have 6 crossings that go across the Willamette River. And all of those crossings are pretty shallow relative to the depth of the soils that are on the side of the river. And so these soils are pretty loose and they're fill, and so they're not super resilient when it comes to seismic hazards. And so our big concern is that during an earthquake, in particular the subduction zone earthquake, we believe that the existing crossings will be damaged badly or fail completely. And so what we're going to do is we're going to provide a crossing that goes from the east side of the Willamette to the west side and provides a seismically resilient water main that will allow us to keep water flowing immediately after an earthquake. So, Jamie, what was the other thing you wanted me to talk about?
Well, I think you just covered the purpose of the project.
Okay, yeah.
So what's happening right now? What's the latest?
Okay, what's happening right now? So we are currently in the exploration stages. So a little bit more detail about the project. It will go from a location that is on the west side of the river near the intersection of NATO and Harbor Way. And so used to be a parking lot there. It's currently called Block J. And so from that location there, we'll hook into the header pipes that are on the west side of the river. And then we're going to go underneath the Willamette, underneath the Markham Bridge, and we're going to come up near a location in 7th and Stevens. So both of those locations are the main tie-in points for the crossing. So at the moment, because underground construction is complicated and there's a lot of unknowns related to it, we have a full-blown exploration program that will allow us to go through and dig a smaller hole, boring, along the alignment as we imagine it. And this will allow us to determine what the soil conditions are, what the groundwater looks like, boulders, any obstructions that we might hit in the near surface. So that is the stage that we're at right now. So we're currently installing what we call a geoprobe, which is basically a fancy way of saying a well casing, except it's on its side instead of going down, it's on its side. And we're going to go underneath the river with that. And so that's what we're doing right now. We're actually making some good progress. So we're learning a lot of good stuff now. And to do that, it's way, way, way better to know if you're going to hit something, you can avoid it, to know if you're going to hit a high groundwater, you can mitigate those hazards. This will make it just much safer and much smoother once we bring in the full-size diameter pipe that will be the size of the pipe, which is about a 39-inch diameter pipe. The current exploration pipe is about 10 inches. So that's our current location and our current strategy and actions at the moment.
Okay, thanks, Tim. So just to let you guys know, we filmed Tim and the job site on Monday. We went out there with a videographer and we filmed him talking about what you're looking at. That geoprobe looks like a huge drill, so it's pretty interesting. It's pretty visually interesting. So I'm going to send everyone clips from the actually what I'm going to do is reissue the press release that I sent yesterday. And I'm going to send the video clips of Tim talking at the site, about the site, and pointing to different things and identifying them. And then there's also some B-roll, so that should be helpful for COIN if you choose to use it. If you don't receive my press releases, then please send me an email and I'll reply to it with the additional visuals. My email address is Jamie, JAYMEE .Cutty, CUTI at portlandoregon.gov, all smushed together. Okay, thanks guys. So Tim will take your questions now. I think I'll kick him off and then I'll turn it over to you all. First question, Tim, why should we care about this project?
We should care because if an earthquake happens, even if it's not the really big earthquake that people talk about, even a smaller earthquake can do some damage to the existing crossings because they're in such soft and loose soils. So an earthquake almost certainly would have some impact on our abilities to fight fire immediately after an earthquake, to maintain water pressure, which means that we would likely have to boil water immediately after an earthquake. So it's the goal of this is to assert our ability to recover in a much faster way, because the problem with the crossings is that they're underwater. And so it is not a trivial matter to go fix something that's deep under the Willamette River, as opposed to, say, if we have a water main break in some street somewhere, you drive up, you close down the street. This is a much more serious matter to fix these crossings. So it's important to have one that will remain intact and serviceable after an earthquake. Just to know the capacity of this crossing will be one where it could accommodate what we normally would have as the average daily demand on the west side of the river. So it won't provide all the water we need for the maximum amount that we imagine, but for the average daily demand, we're going to be able to accommodate that through the new crossing. So it's important for the immediate emergency response after an earthquake that we have water available, and also for the long-term recovery of the Portland metro region to have water available. We know that if there's no water, people are not going to come back. And so that dramatically impacts our ability to recover in a timely fashion. So that's why we should care. That's why I care.
Thank you.
Because I live on the west side of Portland, so and I will say, having this is not just a west side of Portland thing to worry about, because when the earthquake comes, there'll be a lot of water that will leak out in a lot of different locations, and so it's important for the east side as well as the west side that we have this capacity to maintain the system and to keep pressure in the system, and this crossing will help us do that.
Great, thank you.
At least for the short term. In the long term, the west side needs to have this better, to have this ability to maintain water.
Questions from the real journalists in the room or from the Aloha curious person? You could just type them up. I'll read them out. We have plenty of time. I'm going to ask Tim to sit here till 11:30.
No.
No, I'm kidding.
Get ready.
Okay, I'll ask another question. Can you run through the timeline of this project with us?
So we're currently in the exploration phase. And so once we finish that, which is estimated to be 4 to 6 weeks completion, we're going to pull all of that data together. We're going to put it in a nice package, and we're going to assess how we believe this would impact the existing design. So at the moment, we're about 30 to 50% complete on the design elements of the project. So once we get that final geotechnical data from the boring, we're going to put that all together, and then we're going to issue the notice to proceed to start the construction. So that is estimated to come sometime in the late fall, October, November timeframe. And then from that, we'll start construction. We're still estimating that the water main will be installed and connected to the existing headers of the system. And we're anticipating a completion date around the late summer, early fall of 2022.
Great, and I don't see any questions yet, but feel free to add them anytime. I'll just keep going. I keep hearing about innovation related to this project. Can you tell me how unusual a project such as this is, or maybe how typical it is, and any techniques that are particularly innovative?
So the big challenge, the technical challenges of this project is we're in a highly urbanized environment. So we're going from the west side downtown core. The entrance ramp onto I-5 is directly below the site. So a highly urbanized core. And then we're going to the east side, which is also a highly urbanized core. So one of the challenges, one of the innovations of this project is that the only places where we will actually see the equipment is at the ends. And then there will be a place in the middle that we will see a shaft. So for a line that's some 4,500 feet long, we will only see construction activities in 3 locations. And so what that does is that greatly minimizes impacts to the neighborhood, greatly reduces the chances of the urban interface challenges that we have in projects like this with traffic and parking and noise. Those things would be just dramatically reduced by these innovations. So we're using a technology called horizontal directional drilling. And that is basically like drilling on the side. So normally drilling, you would imagine drilling and boring. We have technology where we can literally drill the hole and we can do it. It's just about any angle that we would want. The other innovation is that we're going to use a technology called microtunneling. And so microtunneling is, you imagine the big Bertha machine or the big tunnels, well, imagine that on a much smaller size, but a similar strategy. You've got a head that's rotating around a central core. And so what we're gonna do is we're gonna use the HDD technology, and we're going to thread that through the microtunnel technology. And what that allows us to do is that allows us to avoid laying the pipe out on the city streets. So we'll literally be able to lay it out and set it and put it all together beneath the ground. And so that greatly minimizes the impact. So that's a big innovation with this project. Normally HDD construction requires you to string the entire pipe length out. So HDD, just to geek out a little bit on you here, I call it the flossing method. So you take a drill rig and you run it through the ground along the alignment, and you put a slightly larger drill stem and you pull that back through, and you put a slightly larger one and you pull that back through, and you do like a half a dozen passes until the diameter of the hole is big enough to accommodate the full size of the pipe. And then what you do is that last time you take your drill and you attach the pipe to it, and you literally pull the pipe through the hole all in one swath. So what that normally means is that you would have to lay out some 44,000 feet of pipe, which we don't have in the inner parts of Portland. That's not available. That would be a very disruptive thing. So we're able to hide that pipe, or not hide it, but store it in this microtunneling location. And so that is greatly minimizes the amount of pipe that we have to lay out in the streets. So any questions on that? That's a little bit technical on how this is all going to go down, but hopefully that made sense.
I still don't see any questions in the chat. If there's a problem with using the chat, you can also text my PIO phone. That's the media line. You can call it day or night. That's what it's here for. The number is 503-823-8064. Monitor 24/7. mostly by me. Text that phone number, any questions that you have right now, and I can him in case the chat is not helpful. Oh, we have one. What is the piping material and joining method?
So to me, it seems a little unintuitive, but the pipe's going to be steel. It's going to be a very large steel pipe. And people will say, well, how are you going to bend a piece of steel pipe? Well, if you give it enough radius, you'll be able to bend the steel pipe. So, and then the nice thing about steel pipe is that you can prefabricate a lot of it. You can weld the joints together. So that's what we're going to be using, is this specially designed steel pipe that will have enough flexibility to accommodate the curves of getting underneath the river.
This person tells me that they are a pipe fitter.
Ah, okay. Well, then we're going to use lap joints and double butt welds.
Wow.
To join it together.
Did that answer your question? I'm going to throw out another of my own until I see another one in the, oh yeah, it does answer the question. Fantastic. Thanks for asking. So what can people expect to see? Either people living on the west side or the east side, or people working on the west side by our job site. What will they be seeing throughout construction?
So the west side will be fairly contained. There's quite a large excavated shaft pit. It's kind of a little, if you drive out through Harbor, even now you can look up and see that it's a three-sided box that we have excavated down some 30 feet. So that zone will be a construction zone, and it will be fairly contained. The part in the middle is a shaft location, and so that's also going to be fairly contained. It's a bit off of the road, so I'm not sure that it will be obvious to anyone. The most obvious location will be on the east side. So on the east side, we'll be in the right-of-way. So we'll be in Stevens, we're going to be in 7th, we're going to be in 10th. So that will be the most obvious location. So it's going to be fairly conventional installation, which is you're going to dig a ditch, you're going to put some backfill in it, you're going to lay the pipe down, and then you're going to put it back together. So it will look like largely any other surface trench technology that we're going to use to install the pipe. During the, and I mentioned in my other part about how we're going to string the pipe all together, and then we're going to pull it back in all at one time. There will be a stage of this project, probably a weekend, maybe a week, where we're going to have to weld the pipe all together. And so during that time, we're going to have to detour through the neighborhoods, because we're going to have to weld together about 900 feet of pipe. And so that's going to span 3 or 4 city blocks. So during that small part of time, we will have some impacts on the east neighborhood.
We do have a community outreach person that works on this project, and her name is Katie Asher, and she'll be in touch with the neighbors and businesses so that they know what to expect throughout the process. She's already been in touch with neighbors and businesses to let them know what they can expect to see and the traffic impacts. Okay, no other questions yet. So I'll ask you, Tim, what challenges do you anticipate with this project, or what challenges have you encountered with this project?
So underground construction is always a challenging endeavor. You only know small amounts of information, you know, however the exploration hole is. So there have been some challenges in the urban core. There's challenges with the existing uses of the site. So dealing with obstructions, dealing with contaminated soils. Both of those have been issues that we've had to deal with. But we've also learned a lot, and we have a lot of people who are really good at this. We're hiring some of the best folks in the nation to manage this work. and they have a really big toolbox. So we hit one challenge, and then we say, okay, what are we doing? What tool do we pull over a toolbox now? So the urban environment definitely creates a lot of challenges with traffic and noise. So we're mitigating those. Probably the bigger challenges are the obstructions that we don't always know are there. The Willamette River has seen a lot of construction, a lot of history in this area. So those things, those can be a challenge. Those create some interesting moments.
Okay, it looks like we're losing KEX. Thank you so much for coming. Look for my press release. Oh, they're gone. Okay, bye. And let's see, I still don't see any questions, but we do still have Coin and Aloha with us. So anything you want to add about what keeps you up at night, Tim? In relation to the project?
Yeah, let's clarify. There's just a lot of moving parts. So I do tend to wake up and say, oh my God, I forgot to answer that email. It's really just so many moving parts. And then ultimately it all boils down to the soil conditions, which we think we have a pretty good handle on, but you never really know how that's going to work. And so I'm quite encouraged that the current exploration has started in earnest, and it looks like we're getting some good data that's going to be really helpful. That definitely helps me sleep at night to know that we've got some good information to work through and to assess and to design our contingencies against, so that we're ready for whatever might come our way. I think we could have a good handle on that.
Okay, and I'll just ask my final question here. It's a chance for you to tell us what excites you about this project. You know, you've had a long career at the Water Bureau and you've been an engineer for a long time. What about this project interests you and should capture the imagination of Portlanders?
Well, the mesh of technology between the microtunnel and the HDD and the open cut, these technologies often are done in singular, and we're going to pull them together in innovative ways. So that I love that part of it. I love how we are pulling things together that normally wouldn't come together to meet the challenges that this project presents. I mean, this is, I love to talk to people about it, because it's just, as I say, I kind of get into the weeds now and then, because that's where my passion lies. Doing press conferences is not my favorite thing, you might.
Tim Collins.
But the part of it that I really love is solving the problems, looking at what we have in front of us, being part of a team that's really innovative and motivated. And the fact that when we're done, we're really going to help Portland in the long term. And nobody knows when that earthquake comes, but to have this in place is really, really going to help a lot of us out. I was part of the team that went to New Orleans after Katrina. The Water Bureau sent several groups of people there. So I know what it's like to be in a place that doesn't have water. I know how that just basically shuts everything down, and it really, you're just in a really hard spot. So, my goal is to avoid, Portland's my home. I don't want it to look like that. I want it to recover and be vibrant again immediately after an earthquake. So there you go. That's my goal, and that's what keeps me going. And I'm a geotech engineer, so I love all this whole thing about drilling and different formations and all that stuff. That's very interesting to me.
Do you have anything, Tim, that you think I missed? Anything that you want people to know about this project?
Well, I kind of gave my why motivated is also why what I want people to know about this is that it is important. The city's at risk right now. I mean, even a smaller earthquake could cause some serious problems related to how we get water across the river. It's a serious problem. So I want I want people to know that the Water Bureau is forward thinking. I want them to know that we are trying to do the best we can to imagine hazards, imagine how we might recover from them, and then to take the actions now necessary to prevent a really serious situation that would come up after a big earthquake. So that is the part that I want people to hear. And you know, these things are expensive, so I want people to know that it's worth it to take these tasks now, to spend the money now to get ourselves more resilient. That will pay big dividends once we try to recover after an earthquake.
And why are we talking about the west side? Why is this helping businesses on the west side and homes on the west side, hospitals on the west side?
Yeah, I tend to, you know, I need to expand my description here, because this crossing will help all of Portland recover. The water, we are talking about the water immediately going to the west side, but to have that ability to do that allows the east side to have the resiliency to keep it running even during, you know, because with the big problems along the Willamette, the system even on the east side is potentially going to drain out after a big earthquake. So it's important that this crossing will help mitigate against that and help the east side of Portland recover as well.
But can you actually explain the path of our water that our watershed is?
Oh, okay. So the watershed is near Mount Hood, and so the water is captured and it's put in 3 large pipes or conduits, and so those pipes deliver water by gravity from the Bull Run reservoirs, which are about 30 miles to the east of here, and they bring the water down through the hills, the foothills, through Gresham and into the distribution system in downtown Portland. So that's why it's important to you know, that's the direction that the water is flowing. So Jamie was saying, well, why does the west side matter? Well, it's because the water is largely on the east side. Both the Wellfield and the Bull Run are on the east side of the Willamette. So that's the general flow of the water. And the fact that it's done by gravity, that even if the electricity goes out, the pumps go off, the water's still going to move down the system and provide some, you know, some capacity to the system, even if there's some leaks in it.
And
or pumps.
our Aloha resident asks, does it help farther west outside of Portland, like say Aloha?
Well, yes. At the moment, we provide water to the west side. And so by having the ability to get that water across the Willamette will definitely allow the capacity to continue to the west side. We have several wholesale customers. I'm not quite sure which one Aloha is. It's TVWD maybe.
You know, your water provider person? If you can tell us your water provider, we can give you more specific information. Like who, TVWD, yes.
Yeah, so for the next 4 or 5 years, they still get their water from us. That's gonna shift. They're building a seismically resilient water main from the Willamette, and I believe that's gonna happen in 2027. But even after that, during a big earthquake, there will be a lot of there will be a lot of issues, I should say. And so having this ability to get the water from the west side through the Portland piping will help assist the TVWD system if we need to borrow the water. I mean, the connections will still be there, even though you won't buy water from us on a general day-to-day basis, to have the connections there. And those connections are directly tied to getting the water beneath the Willamette.
And I would just add that that's part of our emergency resilience plan, is that whoever has the functioning system, the partnerships are already in place that we'll be sharing and supporting each other, regardless of whether we continue to be the primary water provider. We'll all be helping each other. Those partnerships are already in place. Okay, I heard you say HDD. Can you tell us what that is, Tim?
That stands for horizontal directional drilling. So this technology came from the oil and gas industry. It is basically a drill rig. It has a rotating stem. Like, I've already done this before. Instead of going down, goes sideways or in some angle, and it has a drill bit on it that literally they can steer it. So they literally, I mean, not like an airplane or a car, but over a series of feet, they can shift the direction of the pipe. And the drill steel is flexible enough that it can, like, you know, over a series of many feet can be, you know, driven. So that's what that stands for. It's quite an interesting technology. It's also fairly constrained. It's, you know, when you think about how big the pipe is that we're going to put in the ground, the piece of equipment that's putting it in is about the size of a semi-truck. So, you know, it's ultimately not a huge piece of equipment that's installing this pipe.
Well, I am out of questions. What about our guests? Thank you for coming. And Tim Collins' name, Tim Collins is Collins. And Tim, your title for the project?
I'm a supervising engineer at the Water Bureau, and I'm the project manager for the Willamette River crossing.
Okay, with no further questions, we're going to close this out. Thank you so much for everyone's time.
Okay.
Thank you, Tim.
Appreciate it. Bye now. Have a good day.
Bye. If anyone has further questions for me, or even for Tim, feel free to email me, Jamie, JAYMEE.Cuddy, CUTI, at portlandoregon.gov, and I'll be reissuing yesterday's press release with clips and video footage. Okay, thank you so much.
Okay.
Bye.